Okay. And then we're going like that, like this. And what I would like to do is open it here just to see if I can see it. So that was too far that way. Let me dial it back some. Keep in mind, I am streaming. Yeah, so I just want you to be aware. Go ahead.
It was about, you remember I asked you about tutoring and if we needed questions and stuff about other classes?
Mm-hmm.
We finally got past what I was talking about. I understood it a little bit, but now we're on a whole different complicated thing. And I understand it, but I feel like I still need some help.
What's the subject?
It's pre-calculus.
Yeah, I can definitely help you.
But man's like, he needs to just put it on the board.
Yes,
to know it.
Okay, so that whole thing that professors do. So ladies and gentlemen, that whole thing that professors do, when a teacher does that, usually that's happening because, you know, we just don't have, hey, we gotta end the conversation. The phone, yeah, we gotta cut it. Yeah. So usually that'll happen because we're just not gonna have the time, you know, in the class to go over every detail. So they're gonna point you in the right direction and turn you loose. And so they're gonna yeah, and then that's what you have to do though. You have to go and seek a tutor. You have to team up with your classmates. Like that's what you have to do. You have to, because it's just not possible to go through every little detail in class. Go ahead.
He never taught any of it. He just flipped it from the board and was the worksheet. He didn't teach nothing.
So then that's one of those life moments where you decide what kind of experience you're gonna have. Are you gonna take charge of your destiny, or are you gonna sit and play the victim? Are you gonna become the victor, or are you gonna continue to be a victim? You have to decide. I know, it's really bad. Go ahead.
And here, can we do reviews too?
Yes. So today is the last of the new material that I'd like to do for exam 1. We're going to go ahead and restrict exam 1 to the first half of chapter 1. So 1-1, 1-2, 1-3. Today we're going to do 1-4 on quadratics. Let's go ahead and let exam 1 be this upcoming Wednesday. There is a study guide loaded on My Math Lab. I'll create a PDF to load in the box that you can use as well. Yeah, but it'll be kind of long, so you kind of have to decide how you want to work that.
Did you hear what I said?
Reviews, right? Yeah, the exam is Wednesday, so possibly Monday we can review, but we need to finish at least section 1-4
So when
today.
are we going to get
The study guide is loaded in My Math Lab already.
the study guide? The study guide is the same thing as the homework, right?
Access My Math Lab.
It's a little bit condensed. It's not all the homework. It's a little bit more selective. Go ahead, do some other.
My Math Lab is okay. It's still for error.
Yeah.
So, are you on an Apple device? How are you trying to access
I'm
it?
on the drawing.
Usually, okay, we'll try to take some time today at the end of class to make sure everybody can get in. Because if 1 or 2 people can get in, everybody should be able to get in. So you might have to like allow pop-ups and allow cookies.
But we don't.
So let me look at it. We'll look at it at the end of class. Yeah, let me look at it in the class. Did you bring your device? Are you doing it on the phone or a laptop? Okay, we'll look at it at the end of the class. Okay. Any other questions, comments, or concerns? Did I pass the attendance already? It's going around? Okay. So just make sure to get your name on the attendance. Okay. Any other questions, comments, or concerns before I get started?
Okay, so if we do it out of the book, you said
every other odd is enough. I think there's a homework list on Moodle that lists the homework as well. Any of that, you just need to be practicing. And you want to bring into the exam
in your notebook, isn't it?
Yeah, a neat, organized homework notebook. So something where, so this is chapter 1, section 1, question, blah, blah, blah. Here's the original question. Here's the work I did associated with that question. You want to have something that's neat that you can quickly flip through and find whatever you're looking for. Okay, that's the best idea. Just pass it. Okay, so if there aren't any further questions, go ahead.
On the exam, I don't know if you went over this, but are the numbers labeled like the standards? Like the 1.4 and 1.
Yeah, I would say like the way you see it on the study guide, it probably looks like that. But I gotta create the PDF. But yeah. So the question IDs will be there, that kind of jazz. Yeah. I don't mind that. Because I've told students that in the past, and they are like, oh, what is this? And it's like, I'm practically giving it to you, but you gotta take advantage of it. Okay. All right. So today, hopefully, I guess it's working. So today we're going to be moving into section 1.4 quadratic equations. Did I share with you all the whole quadratic formula last time? The negative boy, that story. Okay. Yeah. Just really quick. Anybody can tell me the quadratic formula? It's just offhand.
Negative b plus or minus square root of b squared minus 4ac
Okay.
all the way to a.
Quadratic formula. This might be a little bit non-PC, but one of the ways that my students, he told it to me, and I was like, oh, that's fantastic. I can remember that. It's kind of like a little movie or a story. The way he remembers quadratic formula, he does the following. He says, the negative boy couldn't decide to go to the radical house because he was square, so he missed out on 4 awesome chicks, and it was all over by 2 a.m. That's how he remembers the quadratic formula. So yeah. Give me a color. I think I heard red. Did I hear red?
You heard orange.
Orange.
You're born on orange.
We can't see nothing.
Oh.
Oh,
Okay. Where's the... He's got to turn the TV on. Can somebody turn the TV on for me? The power button is on this end somewhere. On the bottom.
I know you're not just kind of.
That's what I was gonna do.
On this end? Oh, on this end on the bottom. Under that red light. Somewhere.
You looking at it.
There it is. I was directing her wrong. Yeah. That's it. Once you press it, it'll kick on.
Oh, I felt. You know how you feel when something is on. I felt like.
Okay. Uh-oh. All right. And let me see. Looks like everything is still okay. It looks like it's working okay.
Pretzels are so good. Oh my god. Especially when they make you feel healthy and they taste good. I'm sorry. I keep forgetting we're recording.
Yeah, it's all good. Yeah, so again, quadratic formula is something of this nature. Everybody be sure to get your name on the attendance. But yeah, this is how, when he said that, it just instantly sunk into my mind. So again, he goes, a negative boy couldn't decide to go to the radical house because he was square. He missed out on 4 awesome chicks, and it was all over by 2 a.m. Yeah, so that's just one of the ways to remember the formula. Some people used to do the song. I can never remember which song. Every time I went to remember, I was singing to a different song, so that was messing me up.
What?
Yeah, they would go like, because it has a rhythm. Oh, so one of the suggestions is every time we use a formula, there's 2 things. So every time we use a formula, you want to have maybe a formula sheet where you're logging all the formulas. So you just want to have a sheet and you just write them there and keep track of it. So then, it might come in handy. Then the other thing is every time you use a formula, whether it's an example or homework or whatever, every time you use a formula, write the formula. Again, what we do the longest, we do the strongest. Okay, so the proof is in the pudding. Repetition is the key. Practice makes what? I would actually I would beg to differ. Practice makes improvement. If it made perfect, you would never have to do it again. And we all know, as humans, when we stop doing stuff, what happens? It goes down. So I definitely agree with the whole idea that practice makes improvement. Yeah, just practice makes improvement. I like that one. Yeah. Okay. Anyway. Okay. So quadratic equation in one variable. This is an equation that can be written in this form: ax squared plus bx plus c equal to 0, where a, b, and c are real numbers, and a is not 0. What would happen if a was 0? What would happen to that first term? It would what? It would cancel out, and then it would no longer be quadratic. What would it be?
Would it be the linear?
It would be linear because the highest degree is. If a were 0, then the highest degree would be a 1. Right. What's the shape of a quadratic? A U-shaped graph. The linears are going to be what? Just a straight line. Okay, I can't think of anything else. Questions, comments, or concerns?
I just felt real smart.
Are we all aboard or all bored? I'm borrowing that one from one of the groups I hang out with. So only boring people get bored.
That's not right.
But that's true. Because I never get bored. It don't matter. I'll never get bored.
I'm bored if you're not doing mathematics.
Okay, I'll accept that answer. All right. That was a good comeback. Okay. All right, second degree equations. Nothing going on special here. Let's see. Can anybody tell me, on the one on the far left, what's the y-intercept? You know what I mean by y-intercept?
Plus 1. Is it 1?
Scratch that. The one in the middle, what's the y-intercept? -5. You see that? So if -5 is the y-intercept in the middle, can you tell me the y-intercept on the one on the left? Set it equal to
0. No.
If we set it to 0, what's the y-intercept?
Oh,
It's the origin, ain't it?
-25, right?
Wait, what?
Negative
Because if
25.
you subtract 25,
Yeah.
I mean, first you set it to 0, then you subtract 25 to get it on the other side.
I'm confused.
Is that right? If you set it to 0, you know.
When
Okay,
you-
maybe I might be jumping the gun a
yeah,
little
but
bit.
you
Yeah.
subtract it.
Yeah.
Okay,
Yeah.
It's the second
Yeah,
minus.
if we set it to 0, then the y-intercept would be -25.
So then, why is... Wouldn't that have to be 0 equals -3x squared plus 4x minus 8?
Minus, no. So usually we force the a to be positive. So what you said was correct, but we would just move it all to the other side of the equal sign.
So 3x squared minus 4x plus
That's 8.
8.
Yeah. Let's keep going though, because I might be a little bit fudging that a little bit, but that's the idea. That definitely works for others. Zero factor property. What does it mean for two things to be a factor, to be factors? What does that mean? Like if I say a factor 9, what would you tell me?
The two things that equal that when you multiply?
Yeah, multiply, right? That's the whole point. So factors are things that multiply to give us something else. So if we say zero factor property, these are going to be two things that when we multiply them, they give us 0, right? So if we have two things that we multiply and it gives us 0, then either what? The first thing is 0 or the second thing is 0. Does that make sense? Because as long as one of them is 0, it's going to force the whole thing to go to 0, more or less. Does that make sense? So if we have more than one thing that multiplies to give us 0, then we just set the first thing to 0 or the second thing to 0. Let's see it in action. Okay, so I think last time I loaded a whole chapter on factoring. Is that right? I did it in class. Did I do that for you all? I loaded the 2 documents. Remember the summary? Didn't I do that with you all? The GCF and then two terms, 3 terms, 4 terms? No? That might be my other class then. Let me, I could do it right now, but I don't want to go through my files just yet. When we finish this section, just remind me to load that, and I'll make sure that you get a copy. I think I did it together, but I did it from my other class. So if you go to Moodle and check our shared box folder, you'll see the syllabus, you'll see the notes, you'll see quizzes, you'll see handouts, and there's one other folder. Inside the handouts folder, I loaded 2 documents on factoring. So in college algebra, for this course, it's expected that you're comfortable with factoring. Now, as my experience with this course, most students are not comfortable with factoring. This is why I have these documents. So if you go to our shared box folder, I loaded 2 documents. I could pull it up right now. This should be there. So I'll go ahead and pull it up right now. So let's go to box. So if you go to Moodle and click on the box link, eventually you'll get to the following thing. Let's go to all files. This is the winner. This is you all here. Entire course. So when you click on our box link, you'll have this. Then I want to go to the handout section. And I think I want to make sure you have your stuff ready for the exam, your notebook. So that's there. Now the handouts, this is something else. The handouts, so these are the 2 documents I loaded. Here's the first one. If it loads. So again, I can't leave this region, but this is a summary of the different types of factoring that you'll come across pretty much for this course. So whenever we go to factor, the first question we want to ask ourselves is there a GCF, a greatest common factor? So if anything is not clear, you want to do a quick search, a YouTube or Google search. How do I find the greatest common factor? How do I so and so? Okay. This is the information age, so this is an open source society. So all the information is there. You just have to go and get it. Now, after we kind of handle the GCFs, we typically have one of the three cases that pops up next. Either we're going to have 2 terms, 3 terms, or 4 terms. If we have 2 terms and we need to factor, it's usually one of these 3. Difference of squares, difference of cube, difference, sum of cubes, right? One of these 3. If any of these aren't clear, do a YouTube search on how to factor difference of squares, how to factor difference of cubes, so on and so on. There are some pretty nifty, interesting ways to do these, okay? So this is just a summary. So if you don't have 2 terms, then the next case might be 3 terms. Now, typically with this one, you know, it's usually a quadratic, and usually the AC method of factoring works. Usually, if it's a quadratic, that I just usually have one technique. It works for just about all of these, if not 80 to 90% of them, somewhere in that range, and it works. Any questions there, we can discuss it later. And then the last scenario that tends to happen is 4 or more terms. If we have 4 or more terms, we typically want to do factor by grouping. So we're going to group them and rearrange the terms in a way, try factoring, and then go out. So as we kind of get the different factoring techniques, it usually kind of follows the same kind of paradigm. If you're not comfortable with any of those techniques, that's where this other document comes into play. So when I first started teaching, I was teaching intermediate algebra, and we had this chapter on factoring and still loading. But what this is an entire chapter devoted to factoring. All the different scenarios that you come across, that's what this chapter is on. If it ever loads this century. But yeah, so I just scanned the whole chapter and loaded it, and I just keep loading it each quarter. Each time I get a new set of students, I make sure that's available for them. But yeah, it's a whole chapter devoted to factoring. I'm gonna let that load in the back. So, but that's there. Okay. Any questions, comments, or concerns? I saw a hand. I think I was ignoring. Maybe the question got answered. Any questions, comments, or concerns? I'm stalling, trying to let this load so you can get an image of it.
So the study guide, we won't have, if we do a study guide, we will print it out, and that's what we do.
You can. Now, let me give you a little warning about that. The questions may or may not come from the study guide, so you decide how you want to work that. It is a good idea to at least be comfortable with every question on the study guide. It is not a good idea to not study. What I mean by that is, in the past, I've had students, they will just print out the study guide, they won't study, they go in there the day of the exam, and they still draw a blank. That's a high probability of that happening if you don't study. Long story short, if you want to do well in my class, just do the homework all the while. Any information I give, it's going to do nothing but help. But if you try to wait to the last minute, it's not going to work. Okay, that's a trap. And students often fall into that. And I try to give them a warning and a heads up, and then, you know. So what this is an entire chapter devoted to factoring. I think it's 6. Yeah, the whole chapter. The whole chapter is devoted to factoring. Okay? So that's what this is. Okay. So if you're not comfortable with factoring, you just go through this, and they have examples and questions and practice there. All right? So that is definitely loaded. All right, that was kind of a mouthful. Any other questions, comments, or concerns?
Okay, you said, where's the,
Okay. So, yeah. So my math lab has a study guide. You can use that for practice. It's probably a good idea to have a copy of that PDF in your notebook. See what I'm saying? And the solutions for the PDF are at the back, at the end of that document. Okay, so you can practice. It's like 30 questions. There's a lot of pages, so that's why I'm saying you decide. Anybody confident in their factoring? Anybody want to factor this? Anybody want to solve? You want to give it a go? Yeah. Okay, so it's markers. You can either do the markers. You can use the electronic board. Come to the board. Set it to 0. Factor.
With the quadratic formula, right? Okay.
I want you to factor. You could use a quadratic formula. Quadratic formula will work here, but I want to see some factoring. You confident in your factoring skills? You know the X method or the box method? You confident? You know the AC method?
oh, AC method.
Yeah?
Now,
Going once?
that's why I said I can try.
Come on. You got it.
Try.
That's okay. So one of my mentors, he would say, you don't have to be great to start, but you do have to start to become great. Yeah, I know. Just that's all you got to do is just breathe and keep moving. They're pretty bad. Okay, so while she's working there, let's get people working at their desk. So while she's working, I'm going to work over here.
So I already did it with the quadratic formula. You want to go ahead and practice it too?
Yeah, I just want some practice. Quadratic is fine, but I really want to see. It is here. I'm going to take a picture. So what I'm going to do is like this. Okay, so I don't know what's going on, but like right before you all came in here, I was so sleepy. Like I was about to pass out. That's how sleepy I was. Go ahead.
Okay, I remember they said something about taking the 6 from right here.
Yeah. So did you set it to 0?
Yeah.
So when you set it to 0, we're going to use the AC method. So you got to say A times C. So 6 times 3 is what? 18. So you're looking for two numbers that multiply.
Oh, yeah, so now this becomes negative 18.
Yeah, so 6 and negative 3 is negative 18. That sounds good. Okay, while she works there, she continues to work. I'm going to work here.
Okay.
You got it?
Yeah.
All right. Keep it going. You good? Let's just hold tight on the for that. All right. Okay. So look. So you have this, right? 6x squared plus 7x minus 3 equals.
Two numbers that I think add together to equal 7.
Right.
It's 9 and 2.
And multiply to give us negative 18.
Yeah, so 2 would be negative.
2 and negative.
Okay, keep going.
Okay,
Okay.
so that means it's minus 2, and you have to put the 6 back right here. Oh, I remember now. Okay.
Almost there.
It's this, and then plus 9, and then let's divide both by 6. But whatever one goes in
Okay. Okay, wait. So wait. You can keep working. I'm going to catch up to where you are. So now, if we're using the AC method, I agree. I'm going to kind of fuse a few different techniques that I've kind of come across. But it's all based on the AC method. So two numbers that multiply to give us negative 18, right? Everybody agrees with that? Now, negative 18 is what times what?
9 times 2.
9 and 2, right?
Well,
So we're going to say negative 2, and then 9 is what times what? 3 times 3, right? Now, well, hang tight. So now, we're looking for two numbers that multiply to give us negative 18, right? And add to give us what? 7. So all we're going to do is go through the factors. So the first was negative 1. Negative 1 times what? And it adds up to what? It adds up these. They add up to 17, so this is no good, right? So let's go on. What's the next one? It's 2. So if I've used this 2, what's left over? 9, right? And these add up to, is this what we're looking for? This is the line that we were looking for, right? So now we're going to rewrite that 7 using the negative 2 and the 9. But what I'm going to use here, I'm going to use the X/box technique that I've seen students use. I'm going to use the box technique. So I'm going to do it like this. I usually go something like this, right? Like that. Let me clean this up a bit. Like that, and like that, and like that, right?
Oh, I know what you're talking about.
Is this okay? So then up in the upper left, we got 6x squared. Bottom right is the negative 3, right? Is this okay? Let's do it. Let's clean it up just a little bit. I'm going to move this down. I'm going to move this. I'm going to move this. And I'm going to move this. This is fine. Okay. So now, and then on the diagonal, we got to use what two numbers? The what? The 2 and the 9, right? So negative 2x plus 9x, right? Is that okay? You see where the greens came from? Is that okay? Now, let's bring it on home. We're right there. What do the 6 and the 2 have in common? They both have what? 2 and x. So the 6 and the 2 both have a 2 and an x. What do the 9 and the 3 have in common? 3. Just 3, right? What do the 6 and the 9 have in common? 3 what? 3 and an x. What do the 2 and the 3 have in common? Negative, right? So then the claim is that, long story short, 3x minus 1, 2x plus 3. How can we confirm whether this is true or not? Foil. If we foil, 3 times 2, 6x squared. We got 9x minus 2x is 7x minus 3. Okay? There's another way. Let me kind of try to touch on what you might remember. Let me show an alternative. So I'm going to copy. Thank you. It's kind of lagging today. So now, this 7x style, again, green. We're going to rewrite that 7 using the 2 and the 9. I'm just trying to jog your memory. So we're going to say, I'm purposely going to put the 9 next to the 3. So I'm going to say negative 2x and 9x, right? Everything else stays the same. Is this okay? I don't know if this is familiar or not. So usually students have one or the other. Right? So now I have 4 more terms. I'm going to do factor by grouping. What can I factor out of the first 2? 2x. What's left over? 3x minus 1, right? What can I factor out of the second 2? Not, yeah, 3, right? Let's back up. If I factor out of 3, what's left over? Okay, give me a color. Let's go. I'm thinking orange. Style. See how those match up? The whole point was for those to match. Now we want to factor out that common binomial factor. And long story short, we'll get our 3x minus 1. And we're left with 2x plus 3. You can use either technique.
Wait. How do you get 3x minus 1?
So they merged. I factored the orange part. I got purple times orange plus a different purple times orange. But the 2 oranges are the same. So I factored out that common orange, and then I wrote what was left over. Does that make sense? So these are 2 different ways of doing the same thing. Now, I was just trying to jog your memory with the second one. We could have stopped at the first one, where we had the 2 purple parentheses. Right, we could have stopped there. But I can't see what you have written. I was trying to jog your memory.
We learned way different.
And there are like several different techniques for these. So you might want to review the way you did it in the past. And it sounds like it'll be fine as long as the numbers work out on a consistent basis. That's okay. You don't have to do it either of these ways. I'm just trying to jog your memory, and I'm just trying to encourage you. Okay? Because there are other ways that actually work. Go ahead.
Technically, yeah, because 3x times 2.
Okay?
Wait, but these 2 still.
Okay, I'm coming because I just didn't want to leave the microphone. Let me come see what you're doing.
Yeah,
So-
I heard it divide way too, but I don't know.
Let me see. So here.
I was trying to start remembering, but I don't know if I
Oh,
can
so you
divide
did this. Okay, so these. Now the problem with this one is because of here.
Yeah, but that's what
y'all used to do.
we used to divide it and see which one goes.
Yeah. So the reason I don't do it that way is like I use a technique called the AC method because when I first started teaching, I was doing something like that, and it was this whole guess and check. And like the guess and check, I was sitting there for like 15 minutes. I knew I was close, but I was like, I wasted a lot of time doing guess and check. I did some research. At the end of that class, a student showed me pretty much what you see on the right. That's in that chapter that I sent you. So, but it was basically this technique called the AC method of factoring. It removes the guess and check. If it is factorable over the rationals or integers or something of that nature, you can use this and there's no doubt. That's a guess and check technique, more or less. I can't do it, but I don't do the guess and check. So, you have to kind of jog your memory and kind of decide how you want to do that. If you can't remember and if these are too much, just do a YouTube search, and they'll walk you through it. They will walk you through it.
That's what I'm about to do. Because
Okay.
this way was easier, and I was gonna answer it.
Okay, so and that's fine because that's the box method. The students showed it to me. That's how they learned it. They taught it to me. I was like, that's fantastic. I think that's easier to see than what I'm doing on the right.
You want me to erase it?
Just I need a mental note. I'll ask you your name in a minute. I don't want to stream it. Okay. So we at least have access to 3 different techniques for factoring trinomials. Okay. You got. I showed 2 on the board. The first one I did was the box method. The second is a continuation called the AC method, and then you have the FAR method down there. You don't need to know all of them. You just need one, right? But the thing you got to watch out for trinomials when the leading coefficient is not a 1. You got to watch out for that. Okay, I think we're okay. All right. So this is good stuff. We need to kind of have these discussions. I got 3x minus 1. Now we're not done. We're not done. We just got past the hurdle. So let's go ahead. Let's copy this. Matter of fact, let me bookmark this. Let's copy and let's paste. Okay. But this is okay. Yeah, we need to still set it equal to 0 and finish it out. So now, at this point, we have 3x minus 1, 2x plus 3. We're setting that equal to 0. Now, what did the zero factor property tell us again? When two things, what?
When they multiply together.
Yeah, when they multiply to give us 0, either what the first thing, either the first thing equals 0 or this last thing equals 0, right? So all we're going to do is say 3x minus 1 equals 0 or 2x plus 3 equals 0. If we solve, add and divide, x equals a third, all right? And subtract and divide, x equals a negative 3 by 2. How do we know if these results are correct or not? Plug it in into the... See, there's that spark. I was like, it's right there. You got it, yes, you got it. You're there. So hang tight, because I saw it. I was like, yeah, this is what she was getting to. So maybe you can do a demo for us, because you might have a different way that I don't do it. Let me get another one. Let's do one on the next one. If you can show it to us, that'll be great. All right, so now let's confirm these results, right? Let me get a copy. Let's do this. I want to get a copy. All right.
Now I got confidence again because Mr. Lee class had me feeling dumb.
All right, let's cut. All right, so here's the original. I'm going to paste. This is the solution that we got. Now, we want to check these in the original, right? With the least amount of manipulations as possible. All right, so what I'm going to do is break out my trusty, dusty, rusty what? Calculator. All right, so when you go, go away, hang tight. Oh no, you're going to make me load this again? Oh, come on. All right, let's see. I agree. Hopefully this works. I want to choose my file, browse, hopefully. All right, let's go here. We're going to go to the calculator. I think it is this one. Should work. This is looking good. Reload and refresh. We are back in business. Okay, cool. Yeah, it's a little bit of a workaround to get this thing working properly. But I went some years, about 3 or 4 years, looking for this, and I could not find it. And I couldn't find it. And then this school, it's all here in the info. They made it, and I've been using it for years now. So I was looking for years, I found it, and I've been using it for years. You can use this when you're studying, but you can't use this on the exam. On the exam, no cell phone calculators, no tablet calculators, no smartwatches, no Google Glass, no sign language, no smoke signals, none of this. Only thing that's allowed is ESP. If you know ESP, then you can use that. You can read people's minds. I can't stop that. But yeah, I don't want to see any of that. Okay, but you can use a regular calculator. You can use your notes, a number 2 pencil. That's it. Okay. All right. No bird calls. No, none of this. Okay. All right. All right. So now let's see how to use this calculator. Let's see how to use the calculator to check this. Right. So I'm going to go to y equals in the upper left-hand corner. I'm going to type the original in as I see it just on the left. Right. So if I say 6x squared plus 7x, right? Cool. I'm going to quit. Now, when we plug in 1/3 for x, what result should we get if it's true? Not -3, but yeah, if we plug in the 1/3 into the original, the output should be a 3. If we plug in the -3/2 into the original, the output should be 3, right? Because they should make it true. So what I'm going to do, you see the clear button? Clear in the upper right hand, near the right-hand top, clear. So to the left of that is a button called vars or vars. I think it stands short for variables. I clicked it. I'm going to go to the right. I'm going to press number 1. So what I'm saying is like f of 1/3. Let's see what happens. Again, the result we're anticipating is a 3, ladies. Ladies, hey. So we got a 3 that we were anticipating. Let's check the other one. If we plug in a -3 by 2, we should also get 3. Okay, that's about the best that we can do. We plugged them into the original, and they checked out. Go ahead. So if you have that, then you would have to type it in. You got to be practicing with whatever you intend to use on the exam. Go ahead.
This is essentially like what finding the zero.
Yeah, you can set it to 0. I mean, like with something like that, I would type like 6. You have to practice it. You have to practice.
No, I'm saying that in this calculator is where you can
Put in
again,
functions.
your problems and put in your problems and it'll be. I encourage you to check it.
Well, yeah, that's fine. I'm okay. Yeah, that's okay because so the way I'm going to be doing my exams is a little bit different than the way I've done it in the past. In the past, I would give maybe like 10 or so questions, and then I would have to go through and grade them by hand, and then it would take forever. So the change that I've been making lately is I've been making the exams multiple choice. So that as long as you can just get the answer, the proper answer, you know, you don't. I'm not going to make a big deal about showing your work right now. Okay, so just get to the proper answer. But I do make multiple exams, so you know that has an implication is to kind of thwart certain things. But if you can consistently get the proper answer, that's all I'm really looking for right now. Just because this is like on a quarter system and everything is so rushed. But it is important to have proper work. I'm just not going to have to what I need to check that kind of stuff right now. Go ahead. Wait. Did I answer your question or? Yeah.
Oh, no, it wasn't a question. I was just
Yeah,
trying to
that's
say
okay.
that-
Yeah, what you said is fine with me for right now. Is that okay? Yeah. Okay.
So you said for this problem, you use the quadratic formula, you could get the same answer.
Did you get the same thing?
No.
You should have gotten 0.333 bar or repeating threes.
No, I thought x equals 2 and x equals negative 9.
Quadratic formula. If you set it to 0 and solve, what's the formula? Tell me the quadratic formula that you have.
I plug in negative 7 plus or minus square root 7. Oh, wait. No.
You found it?
No. Okay.
Wait. Before you do the plugins, what's your formula?
Negative b plus or minus square root of b squared of minus 4ac all over today.
Okay. So then the negative b, you had negative 7 plus or minus the square root of 7 squared minus 4 times 6 times negative 3.
Which is negative 18. Right?
4 times 6 times so negative.
Also,
I think you may have missed that 4. B squared minus 4ac.
Yeah, I did negative 4. Then it was ac, which is negative 18, so I did negative 4 times negative.
Okay, let's see the quadratic. Give me a color that we haven't used.
Brown.
Okay, brown is fine. So the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, right? So then we said negative 7 plus or minus the square root of 7 squared minus 4. A was what? 6, okay. 4 times 6 times negative 3, right? That's a 7. All over 2 times 6, is that right? Did you have that?
Yeah, I think I multiplied 6 times negative 3 first instead of negative 4 times 6.
Well, that's fine. Because 6 times 3 is 18, but then you got to say 18 times 4. So 40, 72? Is that right?
Yeah.
So 49 minus 72, you would have gotten, that's not right. What's going on?
I got 49 plus 72.
Yeah, plus, 49 plus 72, right?
And then I added it, and it was 1.1.
Okay, here, let's see. So let's say 7 squared minus 4 times 6 times a negative 3. You got 121? Okay. So if you got 121, negative 7 plus or minus the root, what's the root of 121? 6 times 2 is 12. So that's a negative 7 plus or minus 11 over 12. So let's see. Negative 7 minus...
Oh, I forgot the... Oh, okay. I think that was it.
Okay. But now that's a powerful exercise because sometimes students only try to stick with the quadratic, and for quadratics, yeah, you can always use the quadratic formula, but it's not always the best route because it's easy to make mistakes sometimes.
I forgot the one for B2, that's all.
That's okay. So you just want to have a few different techniques ready to go. Quadratic, you definitely want to have it ready to go. You want to be able to factor, these things of this nature. Okay. All right, that was a fun little time. Trying to see the clock. Okay, we're good to go. I am going to keep moving forward. So I think we finally got those results. We checked them, so I think we're okay. All right, let's move forward. Going to get rid of the calculator. And actually, I want to do something like this. Okay. So the square root property. A quadratic equation of the form, that's x squared equals k, can also be solved by factoring, right? If we have x squared equals k, we set it to 0, then we can look at it as a difference of squares. So that's going to be x minus root of k times x plus root k. So then if we solve, we're going to get x equals plus or minus the root of k, right? But that's the same, the square root property, this is essentially saying we can essentially just do, if we have x squared equals k, then we can just jump straight to x equals plus or minus the square root of k. Is that okay? Okay, I'm going to keep moving. Yeah, I thought that was kind of funny. Anyway, okay. So so what we're saying is that the solution set of x squared equal to k is going to be plus or minus root k. So it says both solutions are going to be real if k is positive. Both solutions are pure imaginary if k is negative. And there should be one more. If k is 0, then there's only going to be a single double solution. There's only one distinct solution. It's like sometimes it's called a double solution because it's counted twice. Is this okay? Any questions here on this slide? Okay, I'm going to move forward. You know this. It's just hearing it out loud and the way I talk is information overload. But you actually know this. The simple thing is this right here. X, and let me clean this up. Give me a color. Okay. So this is supposed to be x squared equals k. Then you have the following. It's a property. It's not even a true formula. It's just a property. Okay, and then this slide is just explaining the property in detail. But all of it sinks in when you start working at examples.
What's the second one? I'm sorry. Okay, yeah.
Okay, plus or minus square root of k. All right, and this is just an explanation. All right, I didn't really want to see the solution. So if we have x squared equals 17, that means x equals plus or minus what? Yeah, you take the square root on both sides, you get plus or minus root 17. The curly brackets? You can say x equals plus or minus the square root of 17. The curly brackets just means a list. So it just means the first thing, comma the second thing. I'm not going to make a big deal about that. The exam is going to be multiple choice. So, I just want you to know that means that it's a list. It's a collection of objects, not an interval.
So when it's like that, it's going to be like that all the time?
Pardon?
Like if it's x squared equals 20, it's going to be plus or minus 20.
Well, let's see. In this one, what's this? Okay, so plus or minus the square root of negative 25, right? So I agree that the square root of 25 is 5. What happens to the square root of the negative? It's I, right? So if you put all that together, plus or minus 5i, yeah, you got it. You're saying it, you got to write it so you'll see it. 5i. Yeah. The I would go in front of the radical. Yeah, but yeah, what you're saying is correct. So, any questions here before I go forward? Let's look at another one.
So you would have done the I first?
Usually it's 5i. I would only go in front if it's a radical. Because it's just for clarity. For instance, say we did something like x squared equals negative 17, right? If we had something like that, we square root both sides, we're going to say x equals plus or minus the square root of negative 17, right? When we do the square root of the negative, we get plus or minus I times the square root of 17. If I wrote it like plus or minus the square root of 17i, it's not clear if that I is inside or outside the radical. You see what I'm saying? So that's why we write it like this. If it's a square root, else don't stress about this. I think you got it. These questions just kind of complicated things. I think you all are okay. I'm not going to go into those details. What have you been doing all this time? Same thing. Look, in the previous, we had something squared equals the right. What did we do? Plus or minus square root, right? This is the same thing. Plus or minus the square root. Anybody want to tell me what to write?
So put radical x minus 4, and then radical.
Okay, that's fine. That's fine. X minus 4 squared, 12. You're saying do this, right? That needs to be there, right? Now, when we have square root squared, what happens? They cancel, right? I think this pops, right? So now, if we do that, what happens? Equals. Now 12. Are there any perfect squares in there? 4, right? So the square root of 4 is. So then what's left? All right. So let's look at the square root of 12. So then the square root of 12. That's the same as 12 is what times what? 4 times 3. So 4 is 2 times 2 times 3. You might be getting confused because I'm doing it. If you do it yourself, I think you'll see it. Because when you're trying to follow this for somebody else, especially with me, it confuses students. Don't worry about it. If you do it, you'll see it. No. Hold on, I'm almost done. So watch. So square root of 12, if you look at the green, square root of 12, 12 is 4 times 3, right? But 4 is 2 times 2. So that means 12 is 2 times 2 times 3. Is that right? Again, I think if you do it, you'll see it. If you
what you did last time.
Yes. So I was like, don't read too much into it. So then, we're looking for perfect groups of 2. Here's one of them. So then that means on the outside, come on, we're going to have our 2, come on, equals square root of 3. This is what we got here. Is this okay? All right, I'm going to let it be. Okay. So let's keep going. Now the whole point with this whole zero factor property, we had something squared equals a number. So then that means that inside part equals plus or minus the square root of the right. It's the same thing in each example, just different little scenarios. Okay? Because the same, what we did here in part C is the exact same thing as we did in part B, which is the exact same thing we did in part A. It's just the numbers change, but the concept is the same. There's an underlying thing. Do you see the pattern between A, B, and C? That's the whole point. Okay, just do the same thing and then catch the changes. Okay, so then the final step, we would do what to both sides? Not the 0, but solve for x. Add 4 to both sides, and then x is going to be 4 plus or minus 2 root 3. Okay, now you can check this by plugging into the original. I'm just going to scroll ahead. 4 plus or minus 2 root 3. It does take practice to check this in the original. And keep in mind, everything that you see me doing on the board, I will load a copy into Box, even you at home. Oh, that reminds me. Hey, my students here. Give me an Easter egg for my other students to find. What? Like I need a password. I need a password or something for them that they gotta find. I just need something that they gotta. No, something simple. I like pancakes, right? Okay. So the Easter egg. This is for the audience that like this because I'm streaming this for my other students. I'm pretty sure they're not watching the videos. So if they're listening and they get the Easter egg of pancakes, like they just email me pancakes, this is only from my other class. This is how I know that I'll give them extra credit.
So we'll just go ahead and watch the videos and see what you put in there. So we can get it.
This is for them. You guys get different kind of extra credit. Yeah, you guys are here.
I'm going to say, if you're doing that for another class, what if you did it for us?
Well, I'm not doing videos for you all, so. But that's why I have you coming to the board. Like I'm noticing who's coming to the board, who's engaging. Like I'm taking notes of these things, and that's why I do. So pancakes is the Easter egg. If you're listening at home, either not in the comments because I don't want other people to pick it up. This is why I said email. So if you email me, if you're in my other class and you hear this, you email me pancakes. That's how I know that you were actually watching the video, and I'll give you some extra credit for that. Okay, but they don't have to watch it. It's just available for them. Okay. All right, that was enough of that. Okay. So now, let's keep moving forward. We're at 1242. Okay. So I think this is done there. Completing the square. I'm just going to do a demo on this. I'll let you read through this on your own. Completing the square can be kind of a challenge. I'm not going to force you to have to know complete the square. If you're comfortable with it, that's awesome. Hopefully I don't confuse you. So just do your best, forget the rest, don't stress, and be blessed. Okay? Yes, yes. All the things in Algebra 2, I expect that you know it, and we're going to use the stuff in Algebra 2 to kind of start going forward a little bit with some of the concepts. Okay, so I'm going to move forward. So let's try some examples on completing the square. Now, whenever we can use the quadratic formula, you can also use the completing the square. It's just that sometimes one is easier than the other. Okay, so you don't have to do one or the other. You just need to have it at your disposal. All right, so we're asked to solve this using completing the square. So what I'm going to do, I'm going to introduce another blank page. Let's bookmark this. Let's copy this blank page. I'm nowhere near the end. Let's copy. I need to increase my speed a little bit. And my bookmark is here. I'm going to paste. All right, so that's gone. We're asked to solve this by completing the square. They have a typo, so we'll fix that momentarily. They put x2, that's supposed to be x squared. Yeah. Okay. Anybody confident in completing the square? Don't worry, because I know that one can be a little bit of a challenge. So not factoring, not quadratic formula, but completing the square. Anybody confident?
So is that, you said that's 2 to the second?
Yeah. You want to give it a go? Completing the square. So the original is this: x squared minus 4x minus 14 equals 0. Have you done it already?
I remember doing square. I mean, we did square.
Here. So come to the tablet for me.
You said
Completing the square. So that's like you know what's the completing the square step? Plus or minus, what is it? B over. So let me do it, because completing the square is a little bit. It's not quite. It's the one where you gotta say.
Is it B over 2A or no?
I think it's B over 2 square. It's either B over 2 square. I think it's B over 2 square, right? Is it B over 2A? I think it's B over 2. It's B over 2? Let me see. Hang on, because I'm drawing a blank myself. Hang on. Yeah, it's just B over 2. It's B over. Yeah. Let's see. I think it's just B over 2. Let's go with B over 2. So the completing the square step. Let's just do this. It's going to come in. We're going to say B over 2 squared. We either do plus or minus or add it to both sides. I am going to add it to both sides. There's 2 different ways to do this. There's a couple. All right, so what I'm going to do, I'm going to move my c term to the right, right? So we're going to have the x squared minus 4x equals a positive 14. Now, the first step is already done for us. The first thing that we need, are you recording a video? Are you recording a video? Yeah. It's fine. It's okay. I was going to say no video recording. Yeah, that's okay. So the first thing is that, give me a color. Let's see.
Yeah, see, and it shows.
No, it's not. It's not dark. I'm
Are
gonna.
you serious? The one time that looks. That's horrible. I like you can see yellow.
Okay, so this pops. Okay, so the first thing that the leading coefficient is already a 1. So that's the first step of completing the square. Because if it weren't a 1, we would have to do something a little different. But it's already a 1, so that's the first hurdle. The second thing, we move the constant to the right-hand side. Where'd it go? Come on. We move the constant to the right, right? Now we're ready for the completing the square step. We're going to say, we're going to add b over 2 squared to both sides. We're going to say plus b over 2 squared here and plus b over 2 squared here, right? What's our b in this case? The negative 4, right? Negative 4 over 2 squared. Negative 4 over 2 squared. Is this okay? All right, let's keep going. So then we get x squared minus 4x. Negative 4 divided by 2 is negative 2 times negative 2 is positive 4. So we're saying plus 4 here. This is also plus 4. Everything else stays the same. Okay? So now, on the left, what does that factor into? We're looking for 2 numbers that multiply to give us what? 4 and add to give us negative 4. What are 2 numbers that multiply to give us 4? Add to give us...
4 and 1. He said, okay, say it again.
So two numbers that multiply to give us positive 4 and add to give us negative 4. Negative 2 and negative 2. Negative. I was looking for negative 2 and negative 2. All right. So we're gonna rewrite. We're gonna factor it into x minus 2 squared, basically, right? Is this okay? Okay. So then we're gonna say equals, what is it? 18, right? Now we're back to where? Does this look familiar? Something squared equals the right-hand side. So now we're back to the zero factor, the square root property, right? Square root property. So then if we square root both sides, we're going to get x minus 2 equals plus or minus the square root of 18. X equals 2 plus or minus root 18. But what do we got to do with that root 18? 9 times 2. Ultimately, the result's going to... Okay. You want to check this in the original. That's the completing the square step. That's the not anywhere. There's a whole procedure. I would say do a Google/YouTube search on how to do completing the square. Yeah, so I would say Google that. Google or YouTube. But there's a few stipulations. Here's a here's a word explanation of the procedure. I'm not going to go through this because I know it's going to be information overload. I just did an example. You can take a picture. I will upload it. Everything you see me doing, I will upload. Before I walk out of the room, I'm going to upload it. Okay? So, completing the square, just things you might want to be Googling. You got completing the square. You got zero factor property. We have, what else have we talked about today? It's a lot. Quadratic, so you want to just make sure, just watch a few videos on these different techniques. Go ahead. Go ahead.
Nine times 2.
Yeah.
3 times 3 times 2.
Yep.
So I never understood how you got the outside numbers.
Okay.
Like,
so if we have 3 times 3 times 2, right? Because it's a square root, we're looking for groups of 2. Every group of 2 becomes 1 on the outside. So for instance, here we have 3 times 3 times 2. 3 times 3 is what? 9. 9 is a perfect square. So then it's going to become the square root of 9 times the square root of 2. What's the square root of 9? That's where that 3 came from.
So that's why so what if it's 2? Okay, so say it's 3 times 3 times 3 times 3 times 2.
So wait, you said 3 times 3 times 3 times 3 times 2. So you have 4 3s, right? So that's 9 times 9. What number is that?
Both of them are 3.
That's 81, right? 81 is a perfect square, right?
Okay, no.
Wait. What's the square root of 81? 9. So on the outside, you're going to have a 9. Now, where you're building, if we had 3, 3, 3, 3, the 2 3s become 1 on the outside. So there's 1 3 on the outside. There's a second 3 on the outside.
So it's 3 times 3?
On the outside to give us the same 9. Yes.
So basically, when you pair it up, that's just 1.
Yeah, every group of 2 inside the radical, in this context, becomes 1 on the outside.
Okay, so then when all of them go on the outside, that's when you multiply.
Yeah. Yes.
Okay, I'm going to say one more example.
Okay.
Just so I can understand it. So if you had 3 pairs of 2s, right?
2, 2. So
it's like
2, 2.
2, 2.
So a total of 6 2s.
So you would multiply 2 times 3, basically. 2
Wait.
times 2 times 2, I mean.
Oh, so 3 2s. So 2 times 2 times 2. How many 2s?
Okay, so you have 3 pairs.
So that's 6 2s, right? 6 2s, right?
So
If you do a square root, you have 6 2s, right? How many pairs are those?
that's 3.
That's 3, right? So you're going to have 2 times 2 times 2, which is 8 on the outside. You
So
see?
then that's 8 on the outside.
That would be 8. That would be 8 on the outside.
Okay, I'm just trying to.
Yeah, I get it. I see what you're getting at. But as you work more examples, it'll become clear. Like as long as you get the gist right now, you practice a little bit later. Go ahead.
So in the blue multiply the denominator, not numerator?
I said the negative 4 divided by 2 was negative 2, and then negative 2 times negative 2 is a positive 4. In the back, there was a question.
For that third,
Mm-hmm.
where's the
Mm-hmm.
How did you get x
I factored. So what I kind of skipped a little bit for here, I skipped this step. 2x and x, right? Two numbers that multiply to give us what? And add to give us, what are those two numbers? -2, -2. That's where this guy came from. Yeah, I'm almost there. Does that make sense? Okay, I'm going to leave that comment there. All right, so we got this result. I'm not checking it in the original. You want to check it in the original. When you get on the exam, just be sure to check. Sometimes what happens, we'll get down to this answer. If you don't check it, that's what I like to call the right-wrong answer. Algebraically is correct, but sometimes it's outside our domain and it doesn't work. Sometimes we got to scrap those. So long story short, just check it and make sure that it works.
How do you put that back in there?
Yeah, for the sake of time, there are a couple of techniques. If you're on a graphing calculator, you can store it. You can hit 2 minus 3 square root of 2 and store it as a variable and then plug it in. It takes a little bit. I would just say practice it. But you can essentially do the same thing we've been doing. Just give it a go. It takes a little bit of grit. Yeah, a little bit of practice to do that one. That's the only reason I didn't do it here. But I can show you like towards the end. Okay? We are not even halfway. The time, we're okay on time. We got a little bit of time. So if I don't finish today, I got to continue on Monday. And then once we finish on Monday, we'll review for the exam. There's something going to be on Wednesday. Completing the square. I'm just going to use what's already here. So this is x squared minus 4x minus 14. Is this the one we just did? Oh, okay, this is a solution. Okay. Yeah, 2 plus or minus the square root of 3. Okay. Now here, so now notice that the leading coefficient is not 1. If we're going to use completing the square, we got to get that leading coefficient to be a 1 first. So we could divide everything by 9 or factor out a 9 from everything. I am going to divide everything by 9. Okay? It's gonna confuse things a little bit. It's going to create some fractions, which we can't be afraid of it. You know, we just got to do our best. Forget the rest. Don't stress and be blessed. So if we divide everything by 9, right, we'll get x squared. 12 and 9, that becomes what? 4 over 3 minus 4 over 3x plus 1 equals 0. So I said each term divided by 9. So now we force that leading coefficient to become a 1. Now we do the same thing we did in the last example. It's just a little bit more challenging because we have fractions, but it's the exact same thing. Different numbers, right? So now we force the leading coefficient to become a 1. So we would move the 1 to the right-hand side, so we get the -1. Now we do the completing the square step. We're going to say b over 2 squared. If we say that 4/3 divided by 2, that becomes what? 4 over... So if we say one fraction divided by another, what do we do? Keep, change, flip, right? So if we say 4/3 divided by 2, it's the same as 4/3 times a half. Times a half.
Oh, yeah, half.
A half. Because you keep, change, flip the second one.
Yeah.
So then 4/3 times a half becomes 4 over 6 squared. Let's see, wait. So, yeah, so when you say by half, it becomes 2 over 3. Squared becomes 4 over 9. Okay? So just give it a go. So we're going to add 4 over 9 to both sides of the equal sign. At this point, we're ready for completing the square. We're ready to factor. So then when we factor, we get this. And then from there, we're back to the example before that. And then, you know, we're all building off of this initial idea. I know it's a lot because of the fractions. You got to just give it a go. Team up. Make sure you have at least 1 or 2 people's contact info in the class. You're going to have to work on this outside of class. We're just not going to have time to do it right now. Okay? So you got to team up. You got to practice and work together. This is a beautiful thing because this is loaded on YouTube, so you can pause. You can go back home and pause, rewind, listen to the audio. You can watch it over and over. You know, you can change the time factor outside of this space right now. Okay? You can do all that as much as you need. Okay? So when you finish it out, eventually you'll get here. You know, and you kind of have to work it. So you want to practice. Make sure you're going through the homework. You're going through the study guide, and just give it some practice. If you can't figure it out, the best way to approach this stuff, in my opinion, if I was in your shoes, do what you can on your own first. Try to get the answer correct as consistent as you can. If you can't figure it out, then you want to team up with a classmate or get a tutor or both. Once you've done what you can on your own and working together with your classmates and tutors and you still can't get it, then when you come to me and I explain it, it'll make sense. If you come to me first, what tends to happen with the students is when I explain it, it goes right over their head and it's information overload. Then they get discouraged. So I don't want to discourage you. I'm just saying the order, do it on your own, then work together, then get a tutor. If that still doesn't work, then when I explain it, it should click at that point. Okay, it should click. Okay? All right, I'm going to pause for the cause. Any questions, comments, or concerns right there? I know that's a lot. You just got to give it a go. Keep practicing. I'm going to move forward. The quadratic formula we talked about, okay? I'm going to let that be. We talked about the negative boy going to the radical house. And whenever it's a quadratic equation, we can use the quadratic formula. Whenever it's a quadratic equation, we can use completeness squared. But we just want to have all of these techniques available at our disposal because sometimes one is easier than the other. Sometimes quadratic formula is the easiest route to take. Sometimes completeness squared is the easiest route to take. Sometimes just regular factoring is the easiest route to take. See what I'm saying? So it's not one is always, rules over them all. You just want to have them at your disposal, because that's how it works.
The square thing is that hard. I think it's easier than the quadratic equation.
Yeah, I can see that. That happens definitely. Let's see. Remember to extend the fraction bar in the quadratic formula under the negative b. Yeah. I don't know what that symbol is. That's a typo. That little wide mouth Pac-Man image is a typo.
I think it's supposed to be the floor and an arrow.
Yeah, probably an arrow or something like that.
And it's kind of
Yeah, it just, yep, probably. All right, so it says using the quadratic formula, the main thing with the quadratic formula is writing it down and filling in appropriate. What's our A in this case? Okay, so yeah, this is a typo. Give me a color. Purple, okay. So this is a typo. The original is actually x squared minus 4x. That's okay. All right, so the leading coefficient is, A is 1. What's our B? And what's C? Positive 2, because we have to set it. We got to set it to 0. So that was kind of a rope-a-dope. Yeah, it was a rope-a-dope. I was setting you up for the fall. So yeah, the C, but only for now. You fail now so that you fail forward. That's how life goes. You fail to success. A million no's and one yes. It's still a yes. Okay. Anyway, I'll just keep saying that kind of stuff. I have it all written down. Anyway. So then once we set it to 0, we correctly identify our A, B, and C. Then we can just plug it into the formula and then crunch the number. That takes practice. Don't assume that you have it, because you know what assume means and making okay? All right, I'm going to keep moving. Any questions before I go forward? All right. I think this is just moving forward. You should be able to arrive at this conclusion. So what's a good idea? Now, after you've kind of completed the homework and to try to ingrain it in your memory, one of my professors would suggest to prepare for a math exam, take a few of the questions from the homework, blank questions with no support, just the original question. Create a mock exam with no support. And then you want to see, can you answer all the questions with no support, no notes or anything like that? That's how a lot of my professors would suggest to prepare for a math exam. And I think it's a good idea. You just make a mock exam. We want to replicate or simulate the real world, real world thing. All right, moving along. We got right at 20 minutes. I'm going to turn up the speed a little bit. Quadratic formula. I'm going to use what's already here. So again, the original 2x squared equals x minus 4. Got some TED Talks going on.
divide everything by 2.
Scratch. No.
No?
Nope.
Are we just quadratic?
Set it equal
Move
to.
everything over.
Yeah, move everything to the left. We want to set it to 0, right? So then we get 2x squared minus x plus 4 equals 0. What's our A? 2. What's our B? And what's our C? Then we can just plug it into the quadratic formula. Now, if we do that, notice that blue part, that's called our discriminant. Is it going to be positive or negative? Negative, right? It's going to be a negative 31.
Why?
1 minus 32. The blue part. So then if the discriminant is negative, what can you tell me about when we go to take the square root? Imaginary or not real, right? So we're going to have two complex solutions. So there's going to be an I in there. So 1 plus or minus I times the square root of 31 over 4.
Oh, just take away the. Oh yeah.
Okay?
This be seeming so stressful.
Again, the stress levels come down with the practice. The reason students get stressed out because they procrastinate.
It just sounds.
Yeah.
Sounds complicated.
Yeah.
When I look at it, I see it.
It's not, and it's not. It's just a long string of simple ideas. Complex. There's no such thing as complex. The complex is just a long string of simple ideas. It's just a long string of simple ideas. It's like a combo. And the reason most people kind of get bogged or discouraged is really overcoming the lazy factor. My job that I've given you as your professor is to remind you of a divinity. I think as a human, that's divine because it's natural to be lazy. There's nothing wrong with it. Energy follows the path of least resistance. It's only natural. We're energetic beings. We're spiritual. So it's like it's natural for the energy to follow the path of least resistance. So most people don't take the time to follow all the breadcrumbs, to follow the dots. But the beautiful thing about being human is that we can make the unnatural natural. We can kind of override that natural tendency and kind of embrace our divinity. So anyway, I'm just here to remind you of your divinity. That's all. Remind you of who you are. Okay, anyway. So practice that. If you have any questions outside of class, let me know. I'll make dedicated YouTube videos. And I can go at a different pace when I'm doing these outside of class. In class, I'm trying to get through the lecture and answer questions, and it's a lot going back and forth. But when you all start using the Ask My Instructor and asking questions from these, then I can kind of change the rhythm and slow it down. I can and make a dedicated YouTube video. All right, so we got a cubic. Okay, so here the highest exponent is a degree 3. Anybody know the shape of a cubic equation?
You showed us that. You said the shape and the cube.
The cubic, what kind of shape does it make when we
Is
graph?
it this a square?
Almost. It's like an S-shaped graph. It's going to be something like this, like an S. Okay?
I almost had it.
Yeah, you were on your way. Okay, let's keep going. We got like 15 slides I'm trying to get through. We got 20 minutes. Solve. Okay, if you were going to solve this, you have x cubed plus 8 equals 0. What would you do?
Subtract A on both sides.
Okay. Cube root. Okay,
That's
that's
gonna be
fine. That's fine.
But you put the radical over the X.
It's going to be cube root. Yeah, it would be the cube root of both sides. So if we have, it would be the cube root of negative 8, and then what's that result? Negative 2, right? Because it's
Negative 2 times negative 2.
positive 4, right? Positive 4 times negative 2 is negative 8. Let's see how the book does it. They do this. Okay. This is called the sum of cubes, right? We have something cubed plus something cubed. Is 8 a perfect cube? So this is one of those binomials I was talking about, right? So I'm going to, I kind of want to show you this chair technique. I'm going to let you discover it. I would say do a YouTube search on how to factor sum of cubes. There's a technique I really like to use. It's called the chair technique. I don't want to introduce it now because I feel like time is running out and I don't want to give you too much information. But to go from the first line to the second line, they use the technique of sum of cubes. I'll show the chair technique really quickly. It's going to be a little bit much, but just do your best to keep up. So if you search, if we wanted to factor this, right? The sum of cubes, I usually do the following, right? First thing I'll do is a small set of parentheses and then a large set of parentheses. The last symbol is always a plus. Since they gave us a plus, that means this is a plus. The next one is always the opposite. I call this the plus sandwich because it goes plus minus plus, right?
I call it the soap, like same, opposite, always.
That's fine. Yeah, that's fine. So again, the last one is always a plus. If they give us a plus, that means this is a plus, and the next one is always the opposite. And it's the same if it were minus. It would be minus plus plus. You know C plus plus? If it were minus, I call that the minus plus plus. All right? So that's the initial setup. So now, if we have x cubed, I will go x, x, x. What times what times what gives us 8? 2 times 2 times 2. I saw it when I wrote it. I was like, look, whatever. You know, it's okay. So now, let's see. Oh, hopefully I didn't break my pen. Okay. So now the chair method, I usually do the following. I go like this. So the first part of the chair is right here. 1. So those 2 go here. Goes like this. Right? So then the next part of the chair is here. This is part 2. Right? The chair. So then x times x is right here. Okay? So then the next part of the chair is right here. 2x. And then the final part of the chair is right here. 1, 2. It's like a sofa, a stool. It's like a chair. This is the back. The black is the back. The red is the seat. You see what I'm saying? So then this is a 4 right here, and that's the 4th step. This was the 3rd. This was the 3rd. So when I do sum and difference of cubes, I use this technique. I got this off of YouTube. This is what I want you to kind of search it. Right at about 15 minutes. But yeah, so to factor sum of cubes, this is the technique I use. I got that from YouTube. You'll see that up there is the same as this right here. Okay? So now, the original we had x plus 8, x cubed plus 8 equals 0. We factor, and we get x plus 2 times this. Again, that's sum of cubes, so you got to look that up. Then, so now, we have 2 things that multiply to give us 0. Either the first thing equals 0 or the second thing equals 0. If we set the first thing equal to 0, we get negative 2. If we set the second thing equal to 0, use the quadratic formula, I think we're going to get an imaginary result, non-real results. All right? Is that okay? Because if you try to solve the second one, you can't factor it. You can't factor this. So then you would have to use quadratic formula or completeness square. Eventually, you're going to get a negative discriminant. So you got to take the square root, you get an I, and then you work it from there. But you get 2 non-real complex solutions there. Okay, so we got 1 real and then 2 non-real complex. So then we get these results here. Negative 2, and then 1 plus or minus I times the square root of 2. The chair.
Okay, so the second circle you did was the x and the 2 in the middle?
So the first circle was the black at the top. Those 2 went where we see the black x and the black 2. The left was the green. That was this next one. That was the x squared that you see. The third was the red, which was x and the 2, which was 2x. And then the last was the blue. Okay? So give it a go. It takes practice. You're going to have to kind of look at this later together. Okay? All right, let me see. We got about 15 minutes. I'm almost done with this section. I would like to finish this. Okay, solve for the specified variable. So in this case, we have a equals pi d squared over 4. It says solve for d. So if we're going to solve for d, what would you do first? Multiply both sides by 4 and divide by pi. Okay, I like that. So then we get d squared equals 4a over pi. So then what? Square the square root. So when we take the square root, we get plus or minus. Yeah, I know. We're almost at the end of class, and it's just, you know, yeah. No, it's information overload. It's just, yeah. This is fair game. But I want to finish now so that you can have the weekend to kind of review. Exam is Wednesday. We can ask questions on Monday. Okay. But this is also why I don't mind open notes, because I know it's kind of jammed. The time is kind of jammed. So that's why I keep encouraging you to take good notes and things of this nature. Okay. Let me kind of wrap this up. So then we got RT squared minus ST equals K. We want to solve for T. So this, like, it's the variable, and then treat everything else like a number. And then whatever you do, when they're numbers, you do the same thing here.
So divide by S to get S.
It's like if we had 2x squared minus, I don't know, 8x equals 9.
You would divide by 8 to get it away from t, right?
You got to set it to 0, factor,
No.
or set it to 0. Maybe use quadratic formula. If you set, so subtract k from both sides. Is that what you were saying?
Oh yeah, if you said treat it like a number, so like say if t
So-
was x, you would like say to get it away from t, you would divide it by 8. Like that's what you mean by treat it like a real number.
You got the idea, but that technique wouldn't work there.
Right, I'm just saying.
Yeah, but yeah, what you're saying is correct. But I'm saying that technique wouldn't work even if there were numbers, and that's the technique that students typically like to do, and it'll lead them astray. Like you just gotta factor. You gotta constantly think factor, because what you're doing is like dividing and trying to, because you're gonna have an x squared and you got an x to the power of 1 term, and a lot of times if you divide, they're still separated. But when you factor, it'll become clear. I know I can't explain it. Just try to give it a go. Let me kind of finish this out because we're almost out of time. So just give me a moment. I see your hand. Wait, you want to explain this one? Give me a moment. But yeah, they use a quadratic formula. They set it to 0 and they plug in the corresponding components into the quadratic formula. That's the simplest way I think to do this one. Okay? It's not that it's easy or anything like that. I'm just saying that I'm under the impression that this is the most simple way to do this one. So, okay. In example 8, we took the plus and minus, but if we were working an example that was working in length, we typically wouldn't take the negative, the minus distance. We would take the positive. The discriminant, so from the quadratic formula, the discriminant is the part that you see in blue, the b squared minus 4ac. Once you calculate the discriminant, it can tell you a lot about the way the parabola behaves. So, a positive perfect square. So say that the discriminant was a positive perfect square, something like 81. Then we should get 2 solutions that are rational, so on and so on. As you work examples here, this stuff should become clear. Trying to talk through it is going to be a bit much. But as you work examples, it'll make sense. It should make sense. If you took the square root, like say you had square root of 17, it's not a perfect square, you're still going to get 2 answers, but they're going to be irrational because you can't get rid of the radical. Okay? I just want you to kind of think about this for a minute and think about what it means. I'm going to let this be for right now. All right, we got about 3 more slides. I'm probably going to leave this as an exercise. I'm going to leave example 9 as an exercise. And I think that takes us to the end. So we have just shy of 10 minutes. Any questions? Oh, what's that one? What is it?
You sure you want to go back to the problem?
Which one?
The first one she gave.
Oh, how you got it? Okay, let's find one. Did another one pop up that can be factored?
It was more than one. But I thought you were gonna give another example.
Can this one be factored? Actually, I need to pause for the cause. I'm gonna stop the stream. Do you have the first one written down already? Yeah. Can you come do it over here on the
Where they can see it.
yeah, where it can be seen? And you got maybe 5 minutes. Okay, so 5 minutes. And if you speak, the microphone is, I think it's over here for the laptop. Okay.
Oh.
You can just have a seat. Yeah. You can just look right here. And you can choose your color. Oh, you need can you go get the original?
Sure.
Can y'all see the original on the board there?
Yeah.
Can you read it off for her? Oh, she got it? Okay. All right.
All right, class. Hello.
So the microphone's over here. Let's start talking about it.
Hello, class. So it's 6x squared plus 9x equals 3.
Is it 7 or is it 9? Oh.
It's
is 7.
It is 7, isn't it?
You right at the top.
What that's so weird.
7. Okay.
Minus 7. So you have to make it equal to 0.
Okay.
So 6x squared plus 7x minus 3 equals 0. So now you have to multiply 6 and 3. That gives you, well, 6 and negative 3, that gives you negative 18.
Okay.
So now you have x squared plus 7x minus 18. Then you have to figure out what two numbers multiply to give you negative 18, but add to give you 7. And I got negative 2 and 9. So then I was taught, since we had to multiply the 6 and negative 3, you have to bring the 6 back down.
Okay.
And you have to see which one it goes into evenly, which is negative 2, and that makes a fraction. So that makes x minus 1 over 3. And then now the 6 goes in front of the x. Plus 9. And then, you want me to show how I checked it?
Wait. No. The other one reduced as well, right?
Yeah. 2.
Hmm?
Keep going.
You
Keep going.
simplify that place. Simplify.
Should it be 2? Not 3 over 2, right? It's 3 over 2 is correct though, right?
Yeah.
Keep going. Just keep going. Keep going. Just keep
I was
going.
going, what?
Keep going.
Oh, okay. So, to check it, it's just, you're just distributing it. So, x times 6x is 6x squared. X times 9 is 9x. Negative 3 times 6x is negative 6 over 3x.
Okay.
And then negative 1/3 times 9 is 9 over 3. So then you make these, you simplify them. So now this is, no, that's 2, sorry. Negative,
You erase that undo.
don't mind me, I'm just messing up.
Because we're almost out of time and I'm like,
Oh, sorry.
yeah, that's okay. Okay. So then what solution did you get? This looks correct. So what's the final solution?
It's back to the first one, that's what I'm saying. That's why it's right.
She was just checking.
Yeah, that's how I was checking it.
Okay.
Was,
So then, yeah.
But yeah. But
The only thing is I probably would have kept it as like x plus 3 over 2. Is it supposed to be like,
these are the two things.
but then you'd have to set it to 0. I mean, because if you set it to 0 and solve, you should get the same results that we got.
These are the two, what are they called?
Factors?
Yeah, the two.
What's the 0? Yeah, so, I mean, this is what worked. This was good. Okay, so let me show you what I mean.
That's how we learned it in.
So then, like if we said x minus 1/3, right? That one equals 0. That one equals x equals 1/3, right? Then the second one, if you solve, you should get the proper result. 6x plus 9 equal to 0. Subtract.
Oh, that make it more, you simplify it more, is what you're saying?
It was just the form. Because we got this result and we got this result, but the way you wrote this one was different than the way we did. But it still leads you to the same proper answer. That's why I kept saying keep going. I probably would have left it as 3 over 2 and 1/3, and you see them there. You see them there as well. Okay, so I did kind of learn a new technique.
I did.
Yeah,
Okay.
yeah. So we learned a new technique. We're just about out of time. Don't go anywhere. I got a solid 2 minutes. Let me stop the stream. Let me go ahead and load this. So I'll load a copy of this PDF. When this bar finishes loading, you'll get a copy of it. This isn't quantitative. This is the winner. 1150, entire class, into the notes. I guess I need to load 1.3, so I'll do that. So this is 1.4. I'll let that load. I'm going to go ahead and stop the stream. Okay. So we'll expect an exam next week, or no, hopefully here.